Alright guys, let's try to solve leetcode question Alice and Bob playing flower game. And this is a terribly written question, as you can probably see in the discussion section, but allow me to make that a little bit more clear for you. So basically, the game goes that Alice goes first, so she has priority, right? And in each turn, a player must choose from one of the lane and pick one flower from the side, and at the end of the turn, if there are no flowers at all, the current player captures their opponent and wins the game. So this is the most important part. What you need to know from this is that this section, at the end of the turn, there are no flowers at all. So what signifies the end of a turn? The end of a turn means that they chose a flower. So how you win a game is that you have to choose the last flower. To win a game, choose last flower. Fair enough? But now it's asking us, the condition is that Alice must win the game. So if Alice must win the game, we see here, so this example kind of clarifies for us where we have n equals 3 and n equals 2. So n is 3 and n2 means the corresponding number of flowers in each lane. Let's give you here, let's say we have 3 flowers. And on the bottom, we have m equals 2, so that's going to be 2 flowers. If you can simulate the possible ways that Alice can win, it sort of goes like this. So what's the first condition? 1 and 2. That means that, okay, possible pairs where x is number of lanes, number of flowers that are picked in the first lane. Okay. Number of flowers. Okay. So you can, this is a maximum number of flowers you can have in each lane. So you can have maximum of 3 and maximum of 2. But we must know that to win a game, she has to choose the last flower. So theoretically, let's say that, let's choose the 3 and 2. Alice's choose this. Let's make it more clear. Alice chooses this flower. Bob chooses but let's say Bob also chooses this flower. Alice chooses this flower. Bob chooses this flower, and Alice takes the last one. So because Alice took the last flower, she wins. You can see that because Alice always goes first, for her to satisfy this condition that she has to take the last flower, that means that, let me add this here, the total number of flowers of n and m must be odd. And you see why this is the case, because if you have an odd number of total flowers of combinations, then if there's 3, if there's 5, the moment Alice takes the first one, she's always guaranteed to get the last one, because Bob will always take the corresponding turn after Alice. This will be Alice, Bob, Alice, and because Alice took the last flower, she wins. And same with n equals 3, n equals 5 here. You see Alice took the first one, and you can see by pattern, Bob, and Alice. So Alice will be able to take the last flower and win if there's a total number of n plus m flowers that are odd. So that's just all we have to do. Very, very simple question. This is just a little basic of math and combinatorics. But overall, just a really, really poorly written question that could have been, well, made easier. Or just scrapped entirely, I guess. So let's see. And so I guess the part we have to calculate now is how do we figure out all those combinations, right? So let's say something like n is equal to 6 and m is equal to 5. So we want to figure out so there's four variables that I want to find out. So there is number of n evens, number of m odds, and you see why this works, because you have to figure out how many odds n has, how many odds m has, how many evens n has, because that will get us, because even plus odd will always give us an odd number, right? So to get an odd combination, you need an even plus odd. So this is one way we can figure it out. Another way we can figure this out is by using n odds and m evens. So this will be also, so this will also net us the same condition where Alice wins, but this is different, right? Because now instead of taking all the evens for n, we take all the odds of n, and because we took the odds of n, conversely we have to take the evens. So as long as we figure out these four variables and we multiply them together, because multiplying the different possibilities. So you multiply n evens m odds, and then you multiply n odds and m evens, and you sum them together, and that will give us a total number of arrangements that we can have. So let's try to get into the coding. We have n evens, m odds. These will go together, and we'll have n odds, and we have m evens. So finding out the evens is very, very simple. Regardless of whether it's an odd or even number, you can just floor divide it by 2, and that'll get us the number of even numbers in between the range. And if you don't believe me, let's give you a quick example. 7, right? Oh, 7 is 1. That's odd. 7 is 2, 4, 6. So that's just 7 floor. So that's just equal to 7 floor 2, which will get us 3, which is correct. And 8 is, well, 2, 4, 6, 8, and that's just floor and divided by 2, which just makes no difference. So that will get us this and this. And the only, I guess, slightly tricky part about this is finding the odds. So let's try erasing that. So if this was 8, we know we have 1, 3, 5, and 7. Okay, so this is, so if it's odd, so if it's even, then you can just do the same thing and it's just floor it by 2 if the number we're trying to define a number of odds for is even. But if it's odd, then we have this last number is also included because we start from 1. So 1, 3, 5, 7, 9. So this is actually n floor of 2 plus 1. So we can do like an if conditional statement where depending on the parity of the number, we can either do floor divided by 2 or add 1 to that floor divided by 2. So we can just implement that right here using Python. This is going to be m floor 2 plus 1 if m floor divided by 2 is odd, because 1 is equal to true. Otherwise, it's just well, divided by 2. And this same logic holds for n as well. Yeah, and after that, as long as we return the combinations for each one by multiplying, right? Because we figure out the arrangements for how many evens and odds, and then we also do the opposite and see if the reverse has anything. N odds and m evens, and this should get us the correct answer. Alright, that works just perfectly fine. And time complexity wise, O of 1, space complexity wise also O of 1. We're not looping through anything. We're just given variables and using just a little bit of math. Alright, and let's try submitting that. 100%. Alright, well, that's all for today.